Hi, today I'm going to explain Newton's three laws of motion with all of these randos that I found on the street that I brought into my home. As an aerospace engineering student with a minor in physics, Newton's laws are some of the most important concepts that I have learned so far. Aside from just classwork, I have used some derivation of these laws almost every day at my internship as a stress analysis engineer. Sir Isaac Newton was an English scientist in the late 1600s. His theories helped define mechanical physics to be what it is today. In 1687, Sir Isaac Newton published his book, Philosophiae Naturalis Principia Mathematica, which translates directly to The Mathematical Principles of Natural Philosophy. In this book, Sir Isaac Newton described his three laws of motion, as well as many other relevant laws to physics, such as the laws of gravity. Newton's first law of motion states, every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. What this means essentially is that nothing can move until a force makes it move. And also, nothing can stop moving until something makes it stop moving. So if we look at this box, and take this box for example, if I'm to set this box down right here, and we exclude all environmental factors such as wind, or the table itself falling apart, or the building falling on top of it, this box will stay right here and never move. But if I push this box like this, assuming it's completely smooth on the bottom and that this table underneath it is also completely smooth, this table or this box will never stop moving until it hits something, like my hand. Newton's second law of motion is a little less intuitive. Newton's second law is primarily mathematical, but it essentially says that a force must have two things to exist. There must be an object that has mass, and that object must be moving at an acceleration. In its simplest form, a force is equal to the mass of the object multiplied by the acceleration of that object. If we can imagine two objects falling from the same height, the force they exert on the ground varies based on their mass. So if we know that the acceleration due to gravity is constant, and we take a feather and a hammer and we drop them from the same height, when the hammer hits the ground, it will make a much larger crater as opposed to the feather. This is due to the hammer having a much larger mass than the feather. Newton's third law of motion says that every force has an equal and opposite force. In engineering, we call these reaction forces. This law essentially describes everything in our physical lives. It explains how airplanes fly, it explains why we can sit down and not slip through, or it explains with this box how it will stay right here and it will never sit here and hover above the table, and it will never fall through the table because the force that this box exerts on the table is equal to its mass times its gravitational constant, which is equal to the force exerted upwards by the table. This also explains buoyancy and why boats float and don't immediately sink. These three simple concepts define everything in our life, from why we don't hover when we sit, to why airplanes and rockets leave the Earth, and why the brakes in our car work when we need them to. So to wrap things up, we know that nothing moves without a force. We know that force is a product of an object's mass and its acceleration. And we know that every force has an equal and opposite reaction force. Thank you. And here you can say goodbye to all of the homeless people that are hanging out in here.
Oh, yeah.